So till now we understood the two rules. Now it's time for the third. Third rule is complementary probability. Now what does this mean? It simply means that probability of A is equals to 1 minus probability of complement of A. That's it. Now let's see using a question how will we solve any question using this rule. That a single dice is thrown twice. What is the probability that the sum is neither 8 nor 9? So let's attempt this question. Sample space is the total number of ways since it will be thrown twice. So it will be 6 times 6, 36. Total ways in which sum is either 8 or 9. That's 2 comma 6, 3 comma 5. 1 is 3 comma 6. 1 can be 4 comma 4, 4 comma 5. 1 can be 5 comma 3. There can be 5 comma 4 because 9 is also there. There can be 6 comma 2 and 6 comma 3. Yes, I think these will complete. These are all the total ways in which sum is either 8 or 9. So the total number of ways are 9. So there are 9 ways. So the probability of coming sum 8 or 9 will be 9 over 36. So it will be 1 upon 4. And since we want to know not coming, not 8 or 9, sum should not be 8 or 9, this will be 1 minus 1 upon 4. This will be 3 upon 4. Yes. This is the answer. Now it's time for rule number 4. The rule number 4 states, this is the conditional probability rule, and it simply states that the intersection A, the probability of A intersection B will be equal to probability of B multiplied by A upon B. B is upwards and B is downwards here. We can also find that from here only, this equation only, probability of A when B is completed can be written as probability of A intersection B divided by B probability of B. Similarly, we can also get the formula for B upon A, that is B, this time this will be A. This is rule number 4, conditional probability rule. This is our next question. It says a hydraulic structure has 4 gates. There is some hydraulic structure, it is having 4 gates which operates independently. So there is no dependency between all these 4 gates. The probability of failure of each gate is given as 0.2. and that the first gate 1 has already been filled. Then you have to find that probability that both gate 2 and 3 will fail. So how we will attempt? Just we will write a type of mathematical equation using this question step by step. First of all, these are independent events. All these four gates are independent of each other. So the probability of gate 2 and gate 3 failing when gate 1 has failed. You have to find this. Since it is independent event, so this will be equal to probability of gate 2 and gate 3 fail. It is just like it is written over here, A and this is B. So probability of A conditional B is equals to probability of A if A and B are independent. So we have used this property and applied it here. So we get probability of gate 2 and gate 3 failure. And since these are independent, we can write it as probability of gate 2 failure multiplied by probability of gate 3 failure, which we have already been provided with 0.2. So it will come out to be 0.04. This is the answer. Now comes the rule number 5th. We will talk about rule number 5th. This is the rule of total probability. Total probability. So in this, let's see. There's any situation in which a work is being done and at first work A has been done. Right? So the probability of doing this work A come out to be probability of A. Then after completion of this work, an event E has been done. So this will be probability of event E when A work is done. Similarly, there can be another event B, so its probability will be simply B. And again the E event has been done, so it will be written as probability of E when B has been done. So when such situation arises, at that time the probability of E is given as probability of A intersection E plus the probability of B intersection E. It is either this side or this side. So for either case we use plus sign. And we already know the formula for this from the earlier rules, rule number 2 I guess. So it will come out to be probability of A into probability of E upon A plus we will get this one. So for this we need probability of B into probability of B. It's simple I guess. This is called the rule of total probability. This is called the rule of total probability. Now let us understand another rule, the last rule, the rule number 6. It is very important. This is Bayes' theorem. What does it say? Let us understand first. In the last rule, we got to know that we can find, for example, there is an event A. After doing some work, we get event A, and then after event A, we do some event E. So the probability will be written as probability of event E when A has been done. So what if I want to know what is probability of A when event E is done? That is just a reverse. So what we are doing, we are given with, say, probability of A when B has been done, and now we have to find what is the probability of B when A is done? Just a reverse. To find this reverse, we use Bayes theorem. What is the Bayes theorem? It is we already know this formula. This can be written as P multiplied. So this will be the formula P A upon E. Okay, now let us understand the Bayes theorem again using a tree diagram. It is the rule number 6. So in tree diagram we are going to draw that there is an event A. Suppose for doing event A the probability was X, and then there comes the event E, and the probability of doing E when A was completed was Z. Similarly, there was another event B whose probability was Y, and then probability of getting done the E when the B was already been done is assumed to be T. So now if I want to know what is the probability of event A when E has been done, just reverse, then the formula would be simply X into Z divided by X into Z plus Y into T, total sum Z. That's it. This is the Bayes theorem. And similarly, if we want to find P, probability of B when E has been done, then it will come out to be YT over ZX or XZ plus YT. So this is what is Bayes theorem. Alright, so this is the question regarding the Bayes theorem, and it says we have two bags. In first bag we are having two red balls, it's a marble, so two red marbles and five green marbles, and in bag 2 we are having two red and six green marbles, and a person uses a coin and he tosses it, and if it comes out to be a head, then he goes to the bag 1 and picks up the marble, and if it comes out to be a tails, then he goes to the bag 2 and draws out a marble. So what's the probability that the marble drawn is correct? You have to find this. So in order to do this question, let's draw a tree diagram. So what we are doing is of getting heads or tails, either heads or tails, we are having the probability of we can either get tails or heads. If we get heads, then this, this. If we get heads, then we go to bag number 1. If we get tails, we go to bag number 2. Alright. From bag number 1 to get red, we have the probability of 2 divided by 7. And getting red from bag 2, we have the probability of 2 divided by 8. So now we need to find probability of red according to the first part of the question. So it will be simply 1 upon 2 multiplied by 2 upon 7 plus 1 upon 2 multiplied by 2 by 8. So half 2 by 7 plus half 2 by 8. This will give probability of red marble. Okay. So this is the second part of the question. The question earlier was this. This is the second part of the question. So it says that given that the marble drawn is red, of which probability we have already calculated, given that the marble drawn is red, what is the probability that it came from back one? So what do we have to find here is probability of back one when red has already been drawn out. So this is simply of the formula. This is like A and B. So probability of back one intersection red upon probability of red. So probability of back one intersection red, this is equal to back one and red, back one red. This is intersection is coming out to be 2 upon 7 into 1 upon 2. 7. The probability of red, this was this part, the total of which will be 15 upon 56. If we solve it further, it will be 8 upon, this is the summary of today's lecture is, firstly we did the probability fundamentals, we understood what are different terms like what is sample space and event. Then the second topic that we covered was types of events, and after that we came to approaches to probability. How do we approach? For this we were having that classical and frequency one. Then we did some of the axioms of probability, and then after completing these axioms we jumped toward the main topic, which is rules of probability. So we did this, and for this we did numericals also. The last previous year gate questions. Thank you very much.